Hello, welcome to our training session on advanced filtering techniques to maximize your data. My name is Bart and I will be guiding you through the many different ways to filter on data in the xyzt.ai platform. So I will be talking about spatial filtering, temporal filtering, and also attribute-based filtering. I will talk about how to combine multiple filters and maybe a little bit more advanced than the other topics is that I will be showing how to do route filtering, basically to find the traffic flow or the movement flow that follows specific routes. I will also show you how to do AI-enabled filtering by using a prompt, using natural language interaction, and that is named Just Ask xyzt.ai. And finally, of course, I will show you how you can save and reuse the filters that you will be making. So why filtering? Well, filtering is really at the core of the xyzt.ai platform. Being a big data platform, you really need to be able to reduce the data to see what you want to find. And as an example on this slide, I'm going to show you how to go from weeks of maritime vessel tracking data, literally tens of millions of data points, find that one specific vessel that does a specific maneuver. In this case, that sails along an underwater pipeline. And I know many of you are maybe not in the maritime domain, but those types of filtering that I will be showing are also applicable to the mobility and traffic domain. And then next I will be showing how using floating vehicle data, which is basically GPS data from millions of vehicles driving on our roads, how to identify the traffic that is following a specific route. In this case, we're going to look at detours from a closed highway, and we're going to show you how you can filter out specific traffic flows and how you can then quantify the amount of traffic following specific routes. So filtering is really extremely important to our users, and it's being used all the time on the platform. It's not going to be a dry session. It's really going to be a demo session. So I'm going to switch to my account using one of the sample data sets in the platform, and I'm going to show you different things. So what I'm doing now is I'm on the visual analytics page, which is the page that is showing you a map. It's also showing you a timeline here at the bottom, and it is also showing you the different properties in the data. And it's a really good place to look at your data and to see what the effect is of filtering on the data, because you get a view on the spatial extent of the data, you get a view on the temporal distribution, and you get also a view on the different properties and attributes in the data. Let me first explain the data. The data is GPS data. It's vessel tracking data. It's basically GPS coordinates from ships. So a ship is at a certain point on the map at sea, of course, at a certain point in time. But also the ship is sailing with a specific speed, with a specific heading. And also the ship has different properties, like for instance, the name of the ship. And all those properties, they are available for filtering, but they're also available for styling and for analyzing, of course. So what types of filtering does the platform give you? First of all, there's spatial filtering. Being a spatial temporal platform, spatial filtering is being used all the time. For instance, if I would zoom in on a certain area, I am doing spatial filtering. So you see that the timeline has updated. And if I zoom out again, it will update again. So basically what is happening, the map itself or the map extent is a spatial filter. And this allows you to explore your data very interactively. So for instance, if I would zoom in on a certain area, you would see that I can see how many ships over time are in that area. I can also see what's the distribution of speed, for instance, the distribution of the headings. You see like there's like two dominant headings. So this is traffic in one direction and the other direction and so on. So this is what makes xyzt.ai a visual analytics platform. It allows you to explore data very interactively. So this is spatial filtering, but this is just one example of spatial filtering. You can also use a controller instead of zooming out and zooming in. You can really select areas and then see what is going on in that area. So you see, I drew this little rectangle here to focus on that area, and it gives me the number of vessels over time. It gives me the number of vessels in total over this time period, the list of vessels. So this is also a form of spatial filtering. Spatial filtering can also be done by using shapes, and shapes you can add as areas of interest, or you can you can draw them on the map. So for instance, here at the top, you can select a circle, rectangle, or a polygon. If you select circle, you need 2 clicks and then you get a shape on the map. So for instance, like this, I create a circle, call it my first shape. And then you can use that shape as a filter. You can directly do that here, and you can select show me only what is happening inside the shape or only what is happening outside, and so on. And I will go into the other spatial filters as well. Once you do that, you see that on the map, you only get to see what is happening inside that area. But keep in mind, all the other statistics, they are updated and computed from your spatial filter. Also here, if you open the dataset layer, which is this one here, which is the data from Spire, the AIS, the GPS data of the vessels, you see that there's now a chip here. And that chip you can just click and then it removes the spatial filter. You can do that on the map as well. You can right click on the shape, you can set the filter again, and then you can click on the X button to remove it. So this is very basic spatial filtering using the shapes that you draw yourself on the map. And it's being used a lot in the platform to find what is happening. I will go in more detail into the spatial filtering later on, but let me move to temporal filtering. And temporal filtering in the platform is there in 2 ways. The first one is a time range. And that one you see here at the bottom, you see that there's a time range from March 5th midnight until March 25, just before midnight. That is basically doing temporal filtering. In this case, it's just filtering on the whole temporal extent. But if I would move one of those lines, I will be looking at a smaller time period. So you see again the map updates, and also here on the right side, those statistics they update. And this allows me to see what is happening over different time periods. I am doing that in a very free-form way by manipulating here on the timeline, very much like I would zoom in and out on the map. And this allows you to explore data and see what is going on. And I will be also showing how you can use this to replay animations of movements. The exact time range that is selected here, you can modify that also by clicking on this wheel icon here, and then you can specify it in more detail. You can be very specific about the exact time you want to filter on. And what's interesting also in the platform, you can use relative times. So instead of using absolute times, you could say, I want to look at time at time window relative, for instance, to the end of the data, the start of the data, and so on. So for instance, I can select a relative time range that just looks at the last day of data. And that's what I'm doing now. On the timeline, it's gonna be a little bit outside of, but I can fit always on the timeline. And I can do that again here. Or there's some shortcuts here. If I right click, I can do, for instance, lock on last day. And this way, this time window, that the filter on the time range is always gonna stay locked, like here. And I can, of course, increase that. Why is relative filtering interesting? Basically, because you can reuse filters over multiple data sets, and then you don't have to care about, okay, what's the exact time range of that data set. Another advantage is that if you have real-time data or constantly updating data, if you set a relative time filter like this, and you create a dashboard, for instance, a widget on a dashboard that shows you the number of vessels, then this will always be up to date. Once there's new data, it will always show you the number of vessels the last 4 days in this case. So that's why relative filtering can be interesting. If you want to release the lock on the timeline, you can do that by clicking release, and now I can again change my time range like I would like. So this is the first type of temporal filtering. The second type of temporal filtering is in the layers panel. And in the layers panel, if you open the dataset layer, there's a styling part, which is the first part here. And there's a filtering part, which is the second part here. And in this area, you can select 3 types of filters: property-based, time-based, or area-based. Time-based, you can go here, and then you see you can filter on hours of day, days of week, months of year. This is, for instance, useful if you're in the mobility and traffic domain and you want to only look at commute traffic. Commute traffic is on the roads is different from the traffic during lunch break or during the afternoon. And that's why this is useful. And so you can select basically hours of day, for instance, every hour that starts with 3, 4, 5, or 6. And then you see on the timeline, you get gaps because we will filter out the data outside of this time range. And then all the statistics, everything you see on the map, everything you see in the statistics is only taking data records within this hour of day time range. So you see this is a second type of filtering in time. It's not definable with a single time range because you can have multiple days, but it leaves out within days or within hours certain records of time. So that's the second way of time filtering. I've discussed spatial filtering, very high level. I've discussed temporal filtering. And then the third part of filtering in the platform is attribute-based filtering. So based on the attributes or the properties in your data, you can define filters as well. And the simplest filter would be to filter on a property, for instance, the type of vehicle or the type of vessel. In this case, we're looking at maritime traffic. And if you look at the vessel types, I can make that a little bit bigger here. You will see that there's multiple types of vessels, and I'm going to increase my UI a bit so you can better see it on the recording. So you see there's cargo traffic, there's tanker traffic, there's other cargo traffic, and so on. And you see the distribution, how the percentage of these vessels. So this guides you in understanding what you're looking at. If I now want to filter on, for instance, only the most common type of vessels, which is in this case cargo traffic, I can again go to my filter panel and I can select a property. I have to select that specific ship and cargo type property first. And you see what it does is it already hints me to cargo all ships of this type. So this list is actually populated based on this list. So it's based on the number of times this type appears. So it's adaptive to your data and it helps you find quickly the most important or the most commonly occurring data. So let me make my UI a little bit smaller again so you get better see. So now you see cargo traffic. You see it's much more less chaotic, I would say. So cargo traffic typically doesn't sail back and forth all the time. They follow shipping lanes. They maybe spend some time in anchorage zones like you see here, but it's less chaotic than what you would get, for instance, if you would filter on another type of vessels, which are, for instance, fishing vessels. You see, it's much more chaotic and all over the place because fishing vessels, they typically try to cover as much ocean to get their catch in. So this is how you do attributes-based filtering. Very simple, based on attributes. If you do it based on numeric attributes, you can select ranges. In this case, for instance, let me show you to filter on speed. You see there's a range slider. You can manipulate that, or you can just fill in the numbers that you want to see. For instance, if I want to have between 0 and 5, I set the number. Don't forget to hit the include button, because only then, when you see the chip here, the filter is set. So now you see what's the effect. you will see only the hotspots of where there's slow maritime movement between 0 and 5 knots. That's what we're looking at. If you want to exclude that traffic, you can, instead of hitting the include button, you hit the exclude button, and then it excludes all those points. And what you see now is also a very smooth plot because it's only showing moving traffic above 5 knots. So this is the very, very basic filtering, and this is why we also put it in the UI behind the basic filter button. What I'll be showing now later is how you can get into many more advanced cases. And I will also tackle how to combine multiple filters and also do sequential filtering. But first of all, I want to give you a very nice use case that combines what I have been doing with some of the other analytics in the platform to answer that first question, to find that specific vessel that was basically sailing over the underwater pipeline. And this is now unfortunately, a very common monitoring use case in the maritime domain, that you want to see which vessels are over underwater pipelines or also cables. So starting again from my whole data set of all the vessel movements in those 3 weeks in the North Sea. I also uploaded a GeoJSON or a shapefile. I don't remember exactly what the format of the file was, but it's a file with pipelines. And you see it's geospatial, so there's pipelines going from the port of Bruges all the way to the north and so on. So just as an example that you can use this data also for filtering, I'm going to show you how to do that. So if I go to the left to the areas of interest, you see that in my project, there's 2 areas of interest. There's drawings that I drew on the map, but there's also this file that I uploaded and that I just enabled. And this one is a file, and I picked it specifically because it's a file with lines. It's not a file with polygons or points. So you can even do spatial filtering with lines. And here you will see that I can set a distance threshold, and I set it to 1,000, which means that whenever I filter using these lines, it's gonna look 1,000 meters left and right from the line. So it's gonna basically create a buffer around the line. So back to my to the platform, and I'm gonna enable the dataset layer. What I can do is I can just right click on the line, and you see it pops up to use that shape as a filter. So it is smart enough to understand that you clicked near the line and that you want to use that as a filter. First thing I'm going to do is I'm going to use an inside filter. And what you see is when I do an inside filter, you see that it's selected within 1,000 kilometers. This is about 1,000 kilometers. You can see from the scale also here that it's selected all the records within a distance of that line. The color coding is still with a heat map. If it's a little bit too dark on the map, what I typically do is I switch to another heat map that goes from orange to yellow, for instance, so that you see that there's quite a bit of data along the pipeline. So we're still searching. We reduced the number of vessels already to less than 2,000, but it's still too much to find that particular vessel. So what I'm going to do now is I'm going to use this area with this number, 3,000. I can copy paste the number here if I want. I'm going to use that in another analytical page that we have. It's called dwell time analysis. And dwell time analysis basically allows you to see how long do ships or cars or trucks or people spend in different areas. And remember, the pipeline is just an area in the platform. So what I'm going to do is I'm going to remove the default selected areas, and I'm going to add in the one that I just copy pasted. So this is the one that I copy pasted from the other place. What you see now is over the last day, the average time that ships spend near the underwater pipeline is only 7 minutes. And that's fine. 7 minutes is fine. It's probably the time to sail a couple kilometers across. So that's perfectly normal. What I can also do is I can look at individual dwell times, and I can do that by selecting this one here. And now I get for all the selected areas, in this case, I only selected one area. I get for every ship, this is the identifier of a ship. I get to see how many times that ship was in the area. And also I get to see when it was there and when it exited again. And this is what's the most interesting. It's how long did the ship spend in that area. And you see the dwell times are typically within minutes. So that's perfectly normal. What I can do is I can sort on this table, and I can sort from the largest dwell time to the smallest dwell time. And now I get to see this particular vessel has been in the area for about 10 hours during the last day only. I could go back 3 weeks and look for all the vessels, but in the last day, I found this vessel spending 10 hours. What I'm going to do is I'm just going to copy paste again with Control C, the MMSI number, which is the identifier of the ship. I'm going to get back to my visual analytics platform or page. And instead of doing filtering on the area, what I'm going to do is I'm going to remove the filter again, and I'm going to just filter on that specific ship. So I copy paste in, I select it, and I click on include. And now you get to see only the route, only the movement of that specific vessel. It's still point-based. So what I'm going to do is I'm going to select trajectory-based. It's going to connect the dots. And instead of doing it by default by the number of records, let me just take a plain color. And maybe what I'll also do is I'll put an icon on the ship. And maybe what I'll also do is I'll put a label. So what you see now is on the timeline, you see that the ship has been reporting the GPS position for the entire time period. So you see number of vessels is 1. Instead of plotting the number of vessels, I'm going to plot the speed so we can see when the ship is moving over time. So you see it's been at port for a number of instances, and then it's moving again. You see it's moving on the map. It's at port again. You see it's not moving. You see it's moving again. Almost the same type of movements. And at some point, you will see, if I replay, you will see that it follows the pipeline. So we're almost getting there. I know it was the last day, so moving to the last day. So now it's getting close to the pipeline. And what you see now, if I replay, you see that it first moves to the south. And then when I move forward, it moves to the north. And it doesn't seem to be a coincidence because it really seems to follow the bands of the pipeline. So this is just an example to show you that filtering can be used to reduce the number of data, but it's really a tool to find out what is going on. And typically an analyst would use multiple places in the platform to figure out what is going on with that specific ship. So in this case, you would see that it followed the pipeline for like this stretch, and then it went back to the port. So this is the first example of basic filtering, and I've just used the basic UI to do so. What I'm going to show you now is that we introduced a feature that allows you to do filtering using AI. And to do so, I'm just going to reload my page, which is going to load the default setting, which I believe is just going to be a heat map. And I'm going to show you that every filter in the platform is represented using a textual representation. For instance, if I would filter on a property or an area, let's take an area, for instance, again, and let me maybe enable the drawing layers again. So my first shape here that you see, if I would put an inside filter on my first shape, you would see that it sets a chip, but also behind the scenes, there's a little piece of code that defines that filter. And in this case, you would see it mentions my first shape. It also mentions an ID of a layer, which is optional. You can leave it out. You could also write something like this. Filter only on the points inside that shape. That's how you have to read this. So this is like a record filter. It filters on all the records in the data, but it only keeps the ones that are inside that shape. So this is the textual representation. And so what did we do is we added the capability to just ask a large language model. In this case, we are using OpenAI for a specific filter. For instance, if I remove this filter again, I could ask the AI to show all traffic leaving from the port of Antwerp, show all vessels leaving from Antwerp. And you see, I don't have to be too specific. I can just use Antwerp, even though this shape that you see here on the map, and let me make the background map a little bit darker. You see that the shape is called Port of Antwerp. So the AI is smart enough to understand that I want to have a filter from Port of Antwerp, not just from Antwerp. So it knows about the shapes on the map. So how do you read this? This is a different filter. This is not a record filter. This is a route filter. And the keyword is asset route. So it allows you to select only those parts of the movements of the routes that comply with the statements in the filter. And this you have to read sequentially. It means that from top to bottom, these are the stages that the movement or the ship in this case has to go through. So it means that first it has to be inside the port of Antwerp, and then it can be anywhere. So this is what we call a from filter. So it only takes traffic, movements, assets from that area, and then also showing the records after that area. And this is extremely useful to do traffic flow filtering. I'll give you one more example in the maritime, and then I'll switch to traffic and mobility to go into more depth into this example. So a typical query could also be show all vessels from Antwerp or Bruges to Rotterdam taking less than 5 days. So I hit the submit button. The query goes to the large language model. The large language model tries to figure out what we're looking for. And then the result comes back as a filter in our own spatial temporal query language. So again, I'm going to switch to the trajectories visualization because I reduced the number of data points so much. And I'm just going to color by a unique color per ship. And let me try to explain you what you see here. So again, the first part is a route filter. It basically selects the vessels that are going from Antwerp or Bruges to Rotterdam, and it only selects the parts that comply with that sequence of stages or states that the ship has to go through. And here you see an or statement, and the or statement just tells the platform it has to be either one of two. So the ship has to be either in this area or it has to be in this area in the first stage. Then it can be anywhere. So it can be here at the River Scheldt, or it can be in the North Sea. It doesn't matter. That's what this any tells you. And then finally, the inside here, it tells you that at some point it should be inside this area. So you see it finds ships that go basically straight towards Port of Rotterdam. It finds ships that go all the way up north in the North Sea. It even finds a vessel here, a ship here, that just follows the rivers towards Port of Rotterdam. So this is basically selecting parts of the movements and only those parts that comply with those sequence of stages. And this is very unique on the market. You hardly find any analytical platform that can do this type of sequential filtering. The last question here in the filter is relates to what I said here at the end, taking less than 5 days. And it's an asset filter. So it basically filters on the result of the asset route, but it filters on not on the records in that route, but on the result of that route as a whole. And you can do different things here. And one of the things you can do is filter on the duration. And in this case, it says less than. It's shorthand for less than. The duration, which is a function that evaluates to the duration, the resulting duration of this query. And it should be less than 5 days. In the platform, it has to be seconds. So even here, the AI was smart enough to convert 5 days to what is it, 432,000 seconds. Now, if you want to change your query, two options. You just modify it here and you rerun the query, or you just change it here in line. For instance, maybe you made a mistake and you don't want the traffic from Port of Bruges. You update it like that in line. These filters, you can just copy paste. You can just select them, do Control C, and just save them somewhere, maybe on a wiki page, on a Confluence page, so that you can reuse them if you want. What you can, of course, also do is you can save your project. You can set a bookmark. And I just also put it in the description here. You don't have to do that because the filter will always be here in the bookmark. So if you reload your page or you go offline and back online, you log in again, you just load the bookmark and you have your filter again. So this is a way to also use your filters. And in the next session, I will show you how you can use the filter that you defined in this page also on other pages. But before doing that, I have a first poll that I want to ask. And the poll is, what functionality should we add next? We have a roadmap, of course, and we're always choosing what to do. The first one is filtering on multiple time ranges. And the use case here is that sometimes you have periods of bad data, or you want to leave out periods of holidays, Easter holiday, Christmas holiday in your analytics. So that's the first topic. Second topic is, you've seen the advanced filtering in action briefly with the OR statement and the asset routes. You could imagine having a graphical user interface to click and to create those filters using graphs. Third option is, you've seen the example with the vessel route along the pipeline. One obvious thing is, why can't you do that automatically? Why can't you detect this vessel automatically and then use a filter that only shows the anomalies? Fourth one, more powerful advanced filtering. The language is already very broad, but some things you cannot do. For instance, we don't have arithmetic on data values. For instance, say that you have properties like speed and heading, and you want to do some computations on those properties and then filter. And then the fifth obvious one, everyone is investing in AI. So maybe some more AI-enabled filtering capabilities. So multiple options, you can click on multiple choices and we'll take it into account into the roadmap prioritization. Okay, moving on to the next example, and I apologize for the mobility people in the session, but now I will finally go to a use case with traffic data. And for this one, I'm going to use a sample data set, and you can find it in your account under the sample projects. It's a sample data set that was kindly provided by Inrix. Inrix is a data provider that provides very high quality floating vehicle data. So what are we looking at? We're looking at, again, at hundreds of millions of GPS positions of road traffic. And you see a density map, 4 weeks of traffic. And let me make a little bit more space here so that you can see what's in the data. So again, a map with a heat map, which is the default that we show, a timeline with number of trips, number of vehicles, and some information on how many trips we're looking at and what the different statistics in the data are. So for instance, many mobility analysts, they use, for instance, the speed property to see what the distribution of speeds are when they look at a specific road section. So what I'm going to show you now is that filtering is not just there to find one specific vessel or one specific car or one specific truck. Filtering is really there also to look at groups of movements. And the use case that I'm going to show you is related to this. If you look at this area, this is a highway. So there's a lot of traffic on the highway. But if you look at those 2 weeks, the traffic on the highway is almost gone. There's a little traffic still, which is mostly construction work. And it's because the bridge here has been demolished and is being rebuilt. And I used it in another training session where I was talking about dashboarding as well. So what I'm going to do now is I'm going to use this example to really show you how to do very advanced filtering on the data. And the question that I want to solve is a question that typically road authorities that are analyzing traffic on the highway want to answer. So if the highway section is closed in this area, does traffic flow using different highways, or does traffic flow through the local roads, the smaller roads? And floating vehicle data is extremely useful for that because you can see everywhere where traffic is flowing. So what I'm going to do now is I'm going to use an example from the tutorials. And that example goes into identifying that traffic that comes from this area and then moves south towards the problematic area, which is here, and you see it here on the Mapbox background. You see that it's cut here, so it's closed. And basically, what you would like as a traffic analyst is that traffic stays on the highway. And the last choice, it's not this one, but the last choice is this crossing. And in this crossing, basically, you want traffic to flow along Highway 1 instead of going south on 45, because if traffic does that, they'd have no other option than using the local small roads to go south. And you see Highway 1 here, it still goes south and people can stay on the highway system. So the way to go about and analyze traffic flow flowing off Highway 1 North towards 45, which is basically the traffic that you don't want, is by doing the following. The first step is to create the shapes that you want. And the first shape I want to do is I want to create a polygon here that basically selects only the traffic that comes from, I call it 1 North. I'll call it 1 North so that becomes clear. And then I could use a filter. I could use a filter from, and then I get all the traffic from this area. But you see, it's also giving me the traffic going north. You see that from means just from that area. It also means traffic flowing north. So what I'm going to do is I'm going to reduce it to the traffic that goes to this area. So I'm going to add another shape and just quickly drawing it like this. 45 south, I will call it. So this is on the 45 going south. And I can use a filter too. And in this case, we're going to see traffic that flows from the north to the south area. What's really interesting now is that you would see some traffic still going north. So what is happening? Well, the traffic that comes from north goes to south can also go like this. It can drive north and then go all the way around and then maybe from somewhere else come to this area. So to further reduce that traffic, I will have to add another condition. I will have to say it should really go from here to there along the crossing here. And that's the next thing I'm going to do. And you see now it gets to be a little bit more complicated and I cannot just start using the simple filters. So what I'm going to do is I'm going to switch to the advanced filtering and I'm going to build up my conditions there. So starting again from scratch, I'm going to show you how to do this filtering based on the advanced traffic filtering. And for that, I'm going to use the editor, which is here. And the editor has some convenience places here, some convenience UI that you can use. For instance, I can insert pieces of text like this just to get access to an area. So what I'm going to do now is I'm going to first create that third shape that I need. And that's my crossing shape. I'm going to call it crossing. And that shape is just going to be used to ensure that we're looking at traffic from north to south, but over the crossing. So instead of using the basic filters, I'm now going to use the advanced filters. And here I can just do inside, and then I can select an area, for instance, north, and I can insert it. And this way I can build up traffic flows. I can say, okay, from north to anywhere. But this is not what I want to do. I, of course, want to do from north to the crossing to south. So what I typically do is I start copy pasting. And instead of saying north to north, I say north to crossing. You also see that it always mentions here the area of interest name. This is the name of the layer. And it means that you can have multiple layers with the same name. In this case, I know I only have one layer, so I'm going to remove that. And it's going to resolve it to that one drawing layer that I have. And I'm just doing this for readability, so that it's easier to follow. So in this case, I have traffic that's first inside north, then inside the crossing, and then what I'm going to do is also inside, the next step is going to be inside, what did I call it again? I think 45 south. While it's updating, and you can follow the updates always here, there's going to be behind the layer, there's going to be a little icon. So now what you get to see is traffic going from north over the crossing to south, but you only see what's happening inside those areas. And the reason is that it only selects the subset of traffic. It only selects the part when those conditions are true sequentially. If you want to see what's happening afterwards, you have to say any. And then it also keeps the records of those vehicles after they exit 45 south. Interestingly, again, if you, oops, sorry, didn't mean to rotate my map, but if you look here in the north, you see there's some traffic. Let me first make maybe the background layer a bit darker so you better see it. There is some traffic here still on this highway. How come? Because we are selecting traffic north to south along this sequence of areas. Well, the reason is that some of those vehicles that we're seeing during the day, they drive and they come back in this area. They drive north again. Maybe they come from another direction afterwards into that area. If you really want to leave out that traffic as well, a better way to use any is, for instance, to use not inside, for instance, a crossing. So this means that after leaving 45 south, the vehicle can never be again inside that crossing area. And you see the map has updated and the points are gone now. So this is another way to restrict your traffic. And you see how powerful the platform is in being flexible in combining all those conditions. So now we're looking at traffic coming from north to south, and you see the picture is pretty ugly. You see traffic coming from north to south in those 2 weeks during the road closure is flowing everywhere. It's flowing everywhere. And if you further restrict the analysis, I think in the tutorial what we do is, there's a little village here, it's called Ludenscheid. Let me show you that village. In the tutorial, we show you how to go even further and create a shape for that village. I call it center now. And look at only the traffic ending in the center. And this is traffic that, traffic that is not ending in the center. So basically what we're going to do then is, after not inside the crossing, you want to say that at some point there is a condition, and I believe the condition will be as follows. There is gonna be, sorry, I'm going a little bit too fast here. There's gonna be an end condition, which says the endpoint, and this is how you define the endpoint, has to be not inside the area with the name center. So this is already a little bit more advanced. And you can always format your text. I think there's a format button here. So you see there's this condition here. So what are we looking at? We're looking at traffic coming from north over the crossing, over 45 south, then never coming back into crossing. And then finally, there's an end condition on the endpoint. So the last point, the last GPS coordinate of the trip has to be there, and it should not be inside center. So this is basically looking at traffic that drives from the North Highway over the South Highway, but that doesn't have to be here. It doesn't have to be in this city area. And you see it's pretty bad. It's pretty bad, and that's what you try to avoid, of course. You try to avoid traffic that drives towards the city but doesn't have to be there. You want that traffic to be on the highway. Before closing with the Q&A, I want to advertise the next session. And the next session is all about trend analytics. And trend analytics is about looking at those trends, number of traffic. And what I'm going to do is I'm going to take a very advanced step now. I'm going to use this filter, and I'm going to show you how you can quantify the amount of traffic on all those different detours. So basically, all this traffic coming from north is avoiding the highway, and it is doing that at different points. Some traffic is still getting off here in the north. Some traffic is only getting off here, more south. You can quantify how much traffic that is. And for that, what I'm going to do is I'm going to, without going into much details, I'm going to create a couple of points on the map that are of interest. So for instance, point A, point B. And let me take another one or a couple more ones like this one. C seems to be popular as well, and D seems to be popular here as well. So I'm taking 4 points on the routes that are being followed in this detour, and now I want to quantify how much traffic flows on B, flows on C, flows on D. I'm just going to copy paste this filter, and I'm going to switch to the trend analytics. And the trend analytics is what we're going to be using in the next training session. And we have two types of trend analytics. We have the regular one and we have the categorized one. And in this case, I'm going to use the categorized one. And what does that mean, the categorized one? It means that you can look at different groups in the data. The first thing I'm going to do is I'm going to move all the way to the bottom, again to the advanced filter, copy paste my filter, so that I'm looking at exactly the same subset of traffic that I was looking at before. And you see, this is, I think it's for the last day now, but you can select more days if you want. Let's select the last week. This is like the trend for the last week. What I'm going to do now is I'm going to plot that by hour of day. And I'm going to change that to a bar chart. You see it's scaled between 150 and 450. And this is like the global number of trips that are following by hour of day all these different detours to avoid the highway closure. And next session, we're going to show you how to do all this type of analysis. What I just want to do quickly now is show you that using this analysis, we can select a number of areas, and I'm going to select the ones that I just created, like this, A, B, C, and D. And what I'm doing now is I'm plotting the number of trips, the number of vehicles by hour of day over the last 7 days, following this specific condition, leaving one in the north, over the crossing, going 45 south, never going to the crossing again, and not ending in the city center. And then you see over time how many cars move along those point A, B, C, and D. And now if you save this image or you put it on a dashboard, you can start monitoring your traffic, or you can start making a report on the relative traffic flows. In this case, you see a lot of the traffic stays on the highway because point B, if I go back, is still on the highway, is still here on the highway, and most traffic gets off at the final point just before the closure of the highway. And it would not surprise you, I think, if you would look at the speed. The average speed is near to zero in that area. So you see it's a lot of congestion. So with that, I'm getting to the end of the session. I think we have some time for Q&A. Couple minutes. Let me look at the chat so you can post your questions in the chat. I see one question already, how to combine different conditions with OR in the filter, in the advanced filter. Well, what I showed already, and let me quickly show that again. Here I showed already how you can combine different conditions with OR, with the OR function, which is a Boolean OR. What you can also do, and let me try to give you an example very quickly, is within an asset route, you can define multiple options. And the way to do that is using a switch statement. And those different options are called legs. So you follow one leg or another leg. And you do that with a switch leg. And then, for instance, the first leg, and the legs are called linear legs, you would define in the first linear leg, and the second leg you would define in the second leg. For instance, this one could be something like you want it to be inside one north, and then it can go anywhere. This has to be any. And then the second leg could be, for instance, I'm just quickly doing something here. Doesn't make a useful analysis or anything. But just to show you what that you can combine those two things. So it's still evaluating the filter. So this basically gives you two options to select parts of the routes. First, the ones that come from the north, and then also optionally the ones that come from the center. So maybe to make it a little bit more visible on the map, let's take A and B. So while that is evaluating, it's now gonna compute traffic coming from A or traffic coming from B. And the first time you use an area in a filter, it might take a few seconds to do that. Afterwards, when you start using it, it's gonna be faster. So let's wait for that. Yeah. So this is the result of that filtering. So it means that you, instead of using ORs, you can also use a very complex sequence of conditions and another very complex sequence of conditions, and just put them with a switch statement next to each other. And then you can have both traffic flows in one analysis. So I hope that answers that question. If not, let us know, then I can go in more detail. Next training then, because I don't see other questions. Next training is May 8th. I gave a little sneak peek of what we're going to talk about. So it's all going to be about trend analytics and all the different capabilities. But maybe to finalize, I would like to ask your input one more time. If we would do more training sessions after the next one, which ones would you like to follow? First one, how to upload your own data. How to perform origin destination analysis, very common analysis in traffic flow analytics. Third one, introduction to the different data types. data set types, including the new movement part data, which is a new data type that we support. How to use the API. For everything that I've shown, there's an API, so you can integrate and automate. And then finally, we also have a feature called data stores. It allows you to store billions or trillions of data points on the platform and then work with that huge amount of data. If you like more than one topic or you think more than one topic is relevant, just vote on all of them and we'll take it up. I'll leave it for a few more seconds. All right, so thank you for your input there and thank you for following this training session. It was really my pleasure. I know it's an advanced topic, but we will send you the recording. We will also send out the tutorial information so that you can try it for yourself again. So thanks again and see you in the next session.